Welcome back to Global Technology, where we explore the machines, the craftsmanship, and the hidden systems that quietly keep our world moving. For over 2 centuries, railroads have shaped nations, carried industries, and connected people across vast distances. Steel rails stretching to the horizon became the backbone of modern civilization. But behind every smooth ride lies a demanding job few ever see. Today, we step into the world of railway repair, where fire meets steel, where precision meets endurance, and where skilled crews work tirelessly to keep the rails safe, strong, and alive. And it all begins with a process as old as industry itself: thermite welding. Out on the tracks, steel rails may look solid and permanent, but in reality, they are constantly under stress. Every passing train, every shift in temperature, every vibration slowly weakens the joints between rail sections. To solve this, engineers rely on a remarkable process known as thermite welding. Unlike conventional welding, thermite doesn't use electricity. Instead, it uses a powerful chemical reaction between aluminum powder and iron oxide. When ignited, this reaction produces molten steel at temperatures exceeding 500 degrees Celsius, hot enough to melt and fuse rail ends into a single continuous piece. The result is a seamless joint, stronger than the original steel itself. It's a process that hasn't changed much in over a century, because it works. But while the chemistry may be simple, the execution requires skill, timing, and absolute precision. In the next section, we'll take a closer look at how this incredible reaction transforms broken rails into a continuous line of steel. Out here on the railway, every movement has a purpose. The process begins with preparation. Not fire, not sparks, but alignment. Crews gather around the rail, working in coordination. Heavy steel clamps are brought in and locked firmly onto both sides of the track. These aren't just supports. They are the backbone of the entire operation. Each clamp is tightened with precision tools. Pulled, adjusted, checked, and checked again. Because before steel can be fused, it must first be perfectly positioned. With the rails secured, the next step begins. A cutting machine is lowered onto the rail, its spinning blade biting into hardened steel. Sparks fly outward in sharp bursts as the machine slices clean through the rail. This is where the old section ends, and where the new joint will begin.
Сейчас я вышлю.
Они что, идиот? Я сказал вот здесь поставить. Ядрит свою маму. Не, ну давай.
Ты тупый, не тупый. Нахуя ты стрелку дошивал, и как ты ставишь, там висал себе, там висал. Ну, сколько смотри.
Once cut, the rail ends are exposed. Workers move in closer, using measuring tools and straight edges to inspect the gap. Every detail matters. They check the height, the alignment, the spacing between the two rail ends. Even the smallest imperfection here could become a problem at high speed. So adjustments are made, slowly, carefully, until everything lines up exactly as it should. Now, the mold is brought in. A heavy, heat-resistant casing is placed around the gap, split into two halves and locked tightly into position. Hands move quickly but deliberately, securing the mold, sealing the edges. This mold will soon hold something far more powerful than steel.
Как руководство пойдет?
Before that happens, the rails must be prepared. A gas torch is ignited. Flames surge forward, bright, intense, controlled. The heat spreads across the rail ends, burning away moisture, raising the temperature of the steel. You can see the metal begin to respond. Dark surfaces warming, edges glowing faintly. This step is critical. Without proper preheating, the weld would never truly bond.
Не трясется. Нет, для себя пишу то, что у вас было? Да. Как будто это чем-то отличается от чего-нибудь.
Посмотреть, что-то непонятное.
Then comes the moment everything has been building toward. The thermite crucible is placed above the mold. Inside, a mixture that holds incredible energy. A worker leans in, ignites the charge, and instantly, a violent reaction erupts. A column of flame shoots upward, brilliant, blinding, almost white-hot. Molten material begins to form inside the crucible, and within seconds, the tap opens. Liquid fire pours downward. A stream of molten steel flows into the mold, bright orange, almost alive. It fills the cavity completely, surrounding the rail ends, binding them into one. At this moment, two separate rails cease to exist. They become one continuous structure.
Видео вырежем. А видео, да, скажи. Будет. Сильно ярко. Не воспринимаешь.
Там легче копать его.
Ну, только на ручных. На автомате он не соображает.
Хватит там яму, хватит.
Хватит котел, хватит.
Два на два, ясно.
А, тепло хорошо.
Надо на накладку ставить. Иначе мы испортим потом. Ну, вон, я на накладку ставить. Да как секрет Кока-Колы. Все пьют, а до сих пор никто не знает, какой рецепт Кока-Колы.
As the reaction settles, the brightness fades. The molten metal begins to cool, slowly solidifying inside the mold. Above it, impurities rise and harden into slag. Below, the real weld takes shape. Once the metal has cooled enough, the next phase begins immediately. A hydraulic cutting tool is brought in. Still hot excess metal, the riser, is sheared away. The cut is quick, powerful, precise, because timing matters. Too early, and the metal is unstable. Too late, and it becomes harder than the tools themselves.
Все, стоп.
Браво, товарищи!
But even now, the rail is not ready. The surface is still rough, uneven, imperfect. So the grinders come out. A rotating disc meets the steel, sending sparks scattering across the track. Workers guide the grinder carefully along the railhead, smoothing, shaping, refining. This is where craftsmanship takes over, because trains demand perfection. At high speeds, even the smallest flaw can become a problem. So they grind and check, and grind again.
Заблокированные 0. Сторона нам, скажу по-честному, на твоей совести останется. Но это командир, самое главное.
Показательно, показательно. И здесь будет так же. Это просто чтобы вон подкладка. Подкладка. Да.
Finally, the rail begins to look whole again, smooth, continuous, seamless. What was once a cut, a break, a weak point, is now one of the strongest parts of the track. But even a perfect weld is only part of the story. Because the rail does not stand alone. It depends on everything beneath it. The sleepers, the fasteners, the foundation that holds it in place. And that's exactly where we're going next.
Мы это уберем до конца коробочку.
Накладка снизу в этой плоскости идет.
Out here, there are no shortcuts, no giant machines, no automation, just muscle, experience, and the rhythm of tools striking steel. It begins at ground level. A worker steps onto the track, positioning his boot firmly against the rail. With a heavy pry bar, he leans his weight into the fastener. The metal resists at first, and suddenly, it gives. One clip loosened, then another, each piece removed by hand, each movement deliberate, practiced. Because these fasteners have held the rail in place under thousands of tons of pressure, and they don't come off easily.
Потом начинаю рыхлить ее. Наверное, по всей технологии будут показывать, как его копать. Ну, правильно. Потому что вот эту визу можно сдернуть так. Понял? А люди не поймут. Как что-то. Поэтому показываю, как правильно.
Once the rail is freed, attention shifts beneath it. The ballast, crushed stone packed tightly under the sleepers, must be cleared. A shovel cuts into the rock, lifting, throwing, reshaping the bed beneath the track. Stone by stone, the foundation is exposed. This isn't just clearing space. It's preparing the ground for precision work.
Ямку будешь показывать?
Да.
Не гулять. Не надо, ты что не понимаешь, что это, можно сказать, дебют мой в киноиндустрии. Я в Голливуд отправлю. Может, где-то в фильме будут снимать. Все, вот это называется откопали шпалу. Теперь моим профессиональным молотком выбиваем подкладку. Сбиваю противоугон. Выбиваю подкладку. Ты не будешь увеличивать, как она идет? Выбираю резинку. Такая же операция. Хуже жар. Теперь по правилам надо сбивать шпалу в откопанный ящик. Беру ее, просто вытягиваю.
Now the sleeper can be removed. The worker grips it with a hooked tool, pulling, dragging. The old timber slides out from beneath the rail, heavy, worn. Weathered by years of use, this sleeper has done its job. Now it's time to replace it.
Легла красиво. Это вторая моя 6-я стопка. За новой иду. Блин, грузовичок этот. Не выключай. Пока, говорю, можно приветы передать в Украину. Можно передать. Каторга. Как не рубал. Воно не чує. Называется готовим постель. Ставим в полу посередине. Понять. Так как этот перегон у нас на барана, поэтому концентратов нет и пюре нет. Теперь затаскиваем к полу.
A new sleeper is brought in, carried by hand, guided into position. It's lowered carefully into place beneath the rail. Not too far, not too shallow. Every inch matters. Because this single piece will help carry the weight of entire trains.
Показал нитку? А? И ровно. И зашиваем.
Placing it isn't enough. It must be aligned. The worker uses a long steel bar, pushing, levering, nudging the sleeper into exact position. Small adjustments repeated again and again, until everything lines up perfectly with the rest of the track.
То есть ты так отошел, как будто что-то изменится, если бы ты тут стоял. Видишь, я танцую.
Then comes one of the most physical parts of the job. A hammer is raised and brought down hard, again and again. Each strike drives the fasteners back into place. Metal against metal, echoing down the rail. There's no machine here to do it faster, just strength, timing, and accuracy.
Это лапа у меня крутит на ту сторону, отвечаю. А ты ж, да, Сань, говорил, подкапывай больше. Она место сдвинулась. Ну ты представь. А все уже закончили, да?
Да нет.
Амазу.
With the rail secured, the ballast must be restored. Loose stone is pulled back in, shoveled, packed, leveled. The worker shapes the bed beneath the sleeper, ensuring even support across its entire length, because without proper ballast, the track will shift, settle, fail.
Это зашил, называется. Остался последний этап. Засыпь. Снимай все. Начнем жопу. Обед. Засыпал его. Пусте.
Final adjustments are made. The area is checked visually. The rail line examined for straightness. Everything must feel right, look right, sit right. What you're seeing here is not just maintenance. It's craftsmanship, a kind of work that hasn't changed much in generations, passed down through experience, refined by years on the track. Because in the end, it's not the machines that keep the railway alive. It's the people, the ones who show up in the cold, the rain, the heat, and do the work that most will never see. But even this kind of labor is only part of the story, because when entire sections of track need rebuilding, something much bigger comes in. Machines that can replace everything in one continuous motion. And that's where we're heading next.
Называется сменить шпалу.
From a distance, it doesn't look like a machine. It looks like a train carrying its own cargo. Rows of concrete sleepers stacked high, stretching along the length of multiple wagons. But this is no ordinary train. This is a moving factory. As it arrives on site, everything begins to unfold. Workers step into position, signals are exchanged, and the system comes alive. At the center of it all, a massive steel structure rises above the track. Suspended, balanced, precise. This is the heart of the operation. Beneath it, the rails are already prepared. Old components have been loosened. The line is ready. Slowly, almost silently, the machine begins to move forward. Not fast, not aggressive, but steady, controlled, relentless. Behind the leading section, a continuous flow of sleepers begins. Old ones are pulled away, new ones are guided into place. Everything happens in motion, no stopping, no wasted movement. Above, the conveyor system feeds fresh sleepers forward. One by one, each piece travels through the structure until it reaches the drop point. Below, workers watch closely. They don't control the machine, but they guide the process, making sure each sleeper lands exactly where it should. Then, a new sleeper is lowered into position, perfectly aligned beneath the rails. At the same time, the rails themselves are held slightly elevated, just enough to allow the replacement to happen. As the train advances, the transformation becomes visible. What was once worn, uneven, aged, is now new. Straight, rebuilt. The machine continues forward, section after section, meter by meter, replacing the foundation of the railway without ever stopping. Around it, workers move with purpose. Some monitor alignment. Others prepare the next section, each person part of a system far larger than themselves. From the front, it looks almost unreal. A towering structure moving slowly down the track, carrying steel, concrete, and precision in perfect coordination. And behind it, a finished railway emerges. Fresh sleepers, aligned rails, a renewed foundation ready to carry thousands of tons once again. What would take days, even weeks by hand, is completed here in a continuous motion. A seamless operation, a moving production line built directly on the railway itself. This is not just maintenance. This is transformation at scale, from fire and molten steel, to raw strength and human labor, and now to machines that rebuild entire railways in motion. The evolution of railway engineering captured in a single line of steel. From molten steel pouring like fire to machines rebuilding entire railways in motion, railroad maintenance is a world of precision, power, and quiet dedication. It's work that most passengers never see, but depend on every single day. And behind every smooth journey, there are skilled hands and remarkable machines keeping the rails alive. If you enjoyed this journey into the hidden world of railway repair, be sure to subscribe to Global Technology, and we'll see you in the next story.